So good day. Today we are going to discuss about cloud computing, and you'll be knowing what is cloud computing and how the cloud computing helps for setting up a digital infrastructure, and what are the services can be run virtually with the help of cloud computing. So now, so this is the agenda. Here you will be knowing cloud computing, virtualization, how virtualization helps for cloud computing, and characteristics of cloud computing, deployment models, and then service model, advantage, and AWS overview. So here I'm going to give an example about the AWS, how AWS works, okay, with related to the definitions and terms that we are going to discuss in this session. So actually, this is the definition which provided by NIST, which is called National Institute of Standard and Technology. It is one of the department in US is providing a standard definition for all the technical terms. Okay. So each and every individuals, based on their understanding, they will be telling about the cloud computing definition based on their understanding. Yes, but actually everything is right. Okay, we don't say that the definition is wrong, but here they have provided a standard definition, a wise definition provided by the NIST, which means cloud computing is the model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resource. Example: networks, storage, and other services that can be rapidly provisioned and released with minimal management effort. It means that there is a dashboard. Okay. So what are the requirements by the user or admin? Easily they can configure by themselves. Okay. So this is the machine I want. This is the storage I want. I required 16 GB RAM and GPU and storage, massive storage and OS. That I can select it in the dashboard. Okay, so these resources are available in the cluster, which is called data center. So in the data center, I'm going to create a computing machine, or I can create a storage for my own purpose or any other resource. Okay, so this can be rapidly provisioned. Just you need to set the parameters, what are the constraints that you need. Okay. And with this dashboard, you can able to set up easily. Okay. And also you can able to release the resource. You can destroy the resource with the help of the management dashboard. Each and every computing technology, that means computer service, when cloud computing service provider, they provide own dashboard for that. So you can able to create it and you can able to release the resource easily with their dashboard. Okay, so here they have 5 essential characteristics and 3 service models and 4 deployment models. Okay, so first one, the characteristics. So if these 5 characteristics met, we can say that is an cloud computing. Okay, one is on-demand self-service, which means that you have a dashboard. Okay, you can create it whatever you want for your project or any other purpose. Okay, you can create it by your own with the help of a dashboard. Okay, this is called on-demand self-service. You need not to depend on anyone. So that is called on-demand self-service and broad network access. After creating the services, resources, just assume you'll be creating a CPU. Okay, so what is the requirement? You will be creating the CPU, and that CPU you are going to access it over the internet or intranet. That is called broad network access. Okay, broad network access. You are going to create a service that you are going to access over the internet or intranet. Okay, that means either you can able to access the resource within the premises or outside the premises. If it is outside the premises, then you will be using internet. Okay, inside the premises you will be using private IP. Okay, and resource pooling, which means that it's a cluster. That in data center you can see all the configured resources are available together in the singular region or various regions. Okay, various regions data centers are available. All the resources are compiled up. That means you are integrating all the resources as a single powerful unit. Okay, for example, you have five machines. You are combining all the five machines. Then all the 5 GB, five machines RAMs you will be get it. So 5 into 2 GB, so it means 10 GB of RAM you will get it. And then similarly 1 GB of hard disk, then 5 GB of hard disk you will get it, or 5 TB of hard disk you will get it. And similarly cores processor. So how much you require? We have a single unit. You can get it 2 GB RAM or 4 GB RAM or 16 available resource. You can take it up. Okay, and then rapid elasticity. It's one more important term, rapid elasticity, which means that you can able to increase your resource. For example, you have created a 2 GB of RAM and 1 GB of, 2 GB of RAM and 10 GB, just say 10 GB of storage. Okay, now you will be required more than 10 GB and more than GPU resource and CPU resources. You can increase it automatically. Okay, that is called rapid elasticity. Okay, you can scale up and you can scale down the resource automatically whenever required. That machine will be increased based on the workload that you are providing to the machine. So increasing the resource and you can decrease the resource automatically. Okay, so that is the uh, advantage of cloud computing. And one more important service which is called measured service. So what are the resource that you have created, storage or application or database, anything, okay, everything will be recorded for billing purpose. That is called measured service. Okay, so you will not be, for example, you say you have a machine but that machine is not compatible to work your project. Okay, so is it a wise decision to buy a new machine? You'll be work only 3 to 6 months period. Okay, for that you can go for a rent. Okay, if you go for a rent, then this service has to be measured for billing purpose. It is also called as an utility computing. Okay, so that's why the one more characteristic is called measured service, which means that all the resources are metered for billing purpose. If these five characteristics met, then that is a cloud computing. Okay, so characteristics defines cloud computing. With this also, many of them given their own definitions. It is an utility computing like that. And next, coming to see deployments and cloud services. Deployment means establishing a cloud environment. Okay, you are going to make a cloud environment that is called deployment models. So in these deployment models, there are private cloud, community cloud, public cloud, and hybrid cloud. First, coming to public cloud, which means that somewhere data center, then these config resources are available. Okay, at some place, some geographical area, you will be creating some resource and you will be accessing at every end. Maximum these services, these resources can be used only through the internet. Okay, for example, AWS, Google, or Alibaba, okay, Microsoft Azure, they are the service providers. Okay, they are all public service providers, and you will be creating an account and you will be creating the resources whatever you want. Okay, so that is the example of public cloud. All the resources will be accessed only through the internet only, because this data center which is not available in the inside the premises. For our campus, if you have own cloud, okay, own cloud, they are setting up only for the academic purpose, and that machines are used only in the within the premises, within our campus. Then we can say that is an private cloud. So those resources we are going to access only through the internet, sorry, intranet. Okay, through LAN you will be accessing the resource. Okay, sometimes, no sir, I want to access it in my hostel or at my home. Okay, then you will be required public in IP to access the resource. Okay, so private IP means you can access only at the premises. If public IP means that resource you can access over outside the premises also, maybe at your home. That is the good example. Okay, so private and public. Public means full and full for own use, own organization purpose. Public means Public cloud, those resources can be accessed outside the premises over the internet, and each and every service will be metered up and also billing. So there is a lot of differences there for costing. Okay, based on the service providers, we have to analyze it, which services can be availed from the service provider. Either you can go for Azure or Microsoft or AWS. Okay, so you have to see the multiple factors like compliance, data compliance, and data security. Okay, all those things we have to look it out, and cost also. Based on that, you can choose the whichever it is flexible to you. You can choose the any one of the cloud to create the resource. And coming to see another one, which is called hybrid cloud. So hybrid cloud, it means that combination of public and private. For example, our Tech University has own cloud computing. Okay, we have enough computing resource, but we are lax in storage. We require more storage. Okay. At the time, you can take some storage from the public cloud. Either we can get it from Google or Amazon or something else. So the combination of public and private is called hybrid cloud. Another one, which is called community cloud, only the community purpose, either hospital or academic, okay, or any other government organizations or schools, okay, like colleges, only specific people's automobile industry or research-based industries can access the cloud environment. Okay, that is called community cloud. Okay, and what are the services can be used? Okay, so far we see only the deployments, means how to establish a cloud computing. Okay, that is called deployment models. And coming to service model, this is the stack which is called, first one is the topmost one, which is called SaaS. Next layer is PaaS. Another one is called IaaS. Okay, if you take your system, you will be having a CPU, right? A bare metal you will be having. On the bare metal, you will be installing some kind of operating system, and then you will be installing the application. Okay, I mean software IDEs. Through that, you will be creating the application. You can access application in the particular computing machine. Okay, so this is the traditional things happen. So based on that, what we are going to provide, whether I want CPU or whether I want an application or whether I want a integrated IDE environment. Okay, for example, IntelliJ AI is an IDE. Okay, this IDE which will be provided by cloud also. Okay, so based on that, it is categorized SaaS, PaaS, and IaaS. Okay, IaaS is infrastructure as service, platform as service, software as service. So infrastructure as service, storage, networks, computing, all kind can be given, can be provided under the stack infrastructure as service. Coming to platform as service, a runtime environment will be provided to the user. Okay, so runtime environment provided to the user for developing an application. That is called platform as service. Okay, and Google App Engine, can take example Google App Engine. Then software as a service, Gmail, Google Storage. This is a software as a service. So here even Gmail. Okay, so software as a service, it means that application, not software, application will be provided to the user. A ready-made product will be given to the user. It is called software as service SaaS. Based on this stack, which is called cloud stack, based on this stack, everything will be provided as a service. Not only these things, everything will be provided as a service, which means the database as a service, security as a service, okay, backup as a service, disaster as a service, recovery. Okay. And these are the few service providers: Amazon, okay, Azure, Google App Engine, Rackspace, Digital, Salesforce, IBM, Bluemix. This is a platform as service. And then HP 3 tera storage, then EMC Square. So these are the service providers, and many service providers are there. It's called Digital Oceans, okay, Cloud, Alibaba Cloud. Okay. Many service providers are there. Okay. And coming to see what is the difference and advantage between the traditional computing environment and cloud computing. So traditional means you'll be seeing the bare metal, you'll be seeing the CPU. Okay. But when it comes to the cloud computing, you will be seeing the window, but those hardware and everything will be get it from somewhere. Okay. You will be getting from somewhere else, somewhere data center, somewhere region, okay, somewhere area, maybe I can take it from Singapore or Malaysia or UAE, any countries. Okay, any continents you can get it. Okay. But you have to choose it wisely. Which region is nearer to the end user, that you have to choose. Because what happened, if you choose nearest server, the latency will be avoided. Latency means there will be a delay. Okay, you access, for example, Amazon, which is located in Mumbai and Hyderabad, Amazon data center. So and Singapore. So these are the places which is near to us. So you have to create only the data center. If the application is used by the Indians, then you have to create nearest edge, and also you have to carefully look it out the complaints where you have to keep. Okay. If you keep your data center at US, then what happen? There may be data leakage based on the data complaint regulations. Okay. So there are a lot of regulations are there. You have to follow. For example, healthcare. There is an HIPAA and PCA cards related, demographic related, persons related. A lot of complaints are there. You have to follow the regulatory things and where to keep your data in a safest manner. Okay, that also you have to consider. And see here consumption. So how to consume the CPU? Directly I'm sitting in the laptop and I'm using the application. This is called traditional. This is one good example. Consumption, direct, dedicated one. So I'm using this PC. It's a dedicated to me. But if I access something from the cloud, just I need to use some client software and I have to access the particular machine my end. So I will not see anything. Okay, what happens? Everything will be comes from the some other data center only. So this is called shared multi-tenancy. One CPU which will be shared to multiple user, but it is an isolated. Just not okay, even you can get it. Okay, dedicated also you can get it. Tenancy or but it's all about cost only. Okay, then ease of use. Then hardware and software procurement, you have to go and purchase, right? If I want to increase my RAM or storage, then I need to go to some shops and I have to buy and I have to insert it, and we have to shut down the system. A lot of complications are there. When you do it in the server, what happen? There will be production will be down. Okay. Even we have a rack servers. Directly you can put a plug and play. Directly you can insert it. Okay, some kind of servers, rack servers. And then scale on demand. So here, self-service. Directly you can request based on the rapid elasticity. You can request. You can increase it the resources. You can increase the resources through rapid elasticity. That is one of the and scalability. Scalability you have to increase any services manually, but here you can do it by demand. Whenever you require, automatically it will scale up and it will scale down. Then availability and any failure happen, you will not get. Okay, you will not get the work. There will be delayed or there will be a delay in work, so production will be down. Okay? But when it comes to uh, cloud computing, you can do it automated recovery. Instantly, your CPU will be migrated to your virtual CPU will be migrated to some other center. Hyderabad, there is some issues, okay, during flood season. Immediately, what happened? There will be a replica. There will be a replica factor that will be moved to either Mumbai or something else. Okay. So anytime anything happen, okay, through the climatic things, okay, you can able to access it seamlessly. That is the advantage of cloud and provisioning. It will take some time if you have to request to the uh, of a particular authority to get any machines. But here it is not like that. If you have an admin user, you can able to do it. You can create any resource within a minute. Okay. And provisioning within a minute, but it will take some month. And another one cost. If you want to buy any physical machine, there will be increase in the capitational cost and operational cost. But here you will be using only pay per use. What are the resource you want? Okay, everything is metered and you will be using. That is called pay per use. Okay. Then another one which is called visualization. So what is the link between cloud and visualization here? So visualization, it is the advancement of visualization is cloud computing. Simply, I can say the advancement or propagation, sophisticated of visualization, okay, is called cloud. Okay, so with the visualization only you can able to do it the segregation of aggregated resource. Okay, which means that you can combine all the resource through visualization, and yeah, after combining all the resource you can divide it whichever you want on demand basis. Okay, that you can able to do it only through the visualization only. So in addition to that, we have a web services. Okay, a powerful web services are there. Through web services, you can able to manage, you can able to set all those things in the dashboard at the user end, and then automatically a machine will be created or resource will be created that can be used by the end user, either internet or intranet through broad access, broad network access. Okay, so that is virtualization. So virtualization technology multiplexing the physical system into multiple systems. Assume here this is my laptop. I can segregate my resources, unused resources. For example, I have a 8 GB RAM. Okay, so I can make it. I will be use only 3 GB RAM. Rest of 5 GB RAM is unused. Okay, so I can create many guest OSs. If I take 1 GB RAM, then I can create three virtual machines. I can install a Linux machine, okay, and I can install Solaris or any other OS also, okay, or Windows also. Then in the PC, what is the OS that is installed priorly? That is called a host system. Okay, on the host system, you will be installing some kind of hypervisor to visualize the hardware. Through visualization, that is called hypervisor. Okay, hypervisor or virtualization software, MM manager, everything is same only. Through this software, you can able to create many OSs. Okay, you see here there is a stack, traditional stack. You will be having a CPU or laptop. Okay, that's called bare metal. On the top, you'll be having an OS, and then you'll be installing the applications. Is it or not? But when it comes to host-based virtualization, on the top of operating system, you can install the hypervisor tool and you can create the many guest OSs. Okay, so you can create only based on the availability of hardware resource, available resource. Okay, so that is host based. Another one, para visualization. Here, instead of installing the operating system, directly you are installing the hypervisor software. Okay, we have many hypervisor softwares are there to visualize the hardware resource. Okay, here the full visualization parallels are same, but when it comes to the parallelization, one OS will be dedicated to guest OS will be used to modify or access the other applications. Okay. So example Zen stack. If you install Zen, then I can make it as a para virtualization. Full virtualization, I have to install VMware, okay, VMware ESX server can use. For host-based virtualization, you can install VMware. Okay, again VMware we have, and then Oracle VirtualBox. These are the softwares is used to visualize the CPUs. Either you're going to install it on the top of hardware or on the top of operating system, or bare metal or operating system. Based on that, it is categorized. It is a host directly installed on the top. It is host-based virtualization on the top of hypervisor, type of hardware. Then it is become full virtualization or para virtualization. So these are the virtualization software. You can make it VMware, Hyper-V, Windows 1, Hyper-V, Parallel, Zen, libvirt, OpenVS, kernel virtual machine, and Citrix, okay, and OpenVS. So these are the visualization softwares which helps to visualize the physical machines. Okay. And hope you understand how the visualization helps for cloud computing. Without visualization, there is no cloud. Okay. So visualization plus web services, advanced web services, which provides cloud computing. Okay. Then AWS is the one of the example for cloud computing. It is the through the AWS web services, you can able to create many machines, you can create databases, you can create security. Okay. So they have huge data center across the globe. Okay. So wherever you want, you can able to create the resources. Okay. And this is the pathway where they have started at 1994 and now it is 2025. So within the 2025, a lot of services they have added in the web service dashboard. Initially, it was developed by Jeff Bose. Jeff Bose, in the year of 1994, they have sold CD, okay, and movies. Okay, they have provide movies service and CDs, and later on they went for Amazon Prime. and then Kindle, and then they have provided basic services like storage, compute. S3 means storage, compute, and then slowly they have increased many resources are backed in the AWS web service. You can open the AWS portal. Okay. Amazon is not provide only the shopping. They provide computing facilities also. They provide various services. Okay. And so around 165 services. Now we have around 200 plus services are there till date. And here the most popular services are EC2 and S3. Okay. If you want to explore as a beginner, if you want to explore more, then first, you have to complete Amazon S3, compute, which is CPU, and then database. Okay. These three is enough for kickstarting the cloud computing through AWS or not in any services. Okay. Any services, you have to start only with these three services, and you will be able to understand the next. Again, many services are there. This is the core foundations. A core foundation. Okay. So if you want to build any infrastructure, the infrastructure or IT technology requires three things: compute, storage, and networks. Compute means CPU, storage. Okay, you can add NAS, SAN, storage as a network or a network attached storage or any storage networks. How to add two or more nodes. Okay. How to provide a digital, create a digital infrastructure, how to add a subnet to the each digital infrastructure, how to make it to the as a single infrastructure, and how to provide security to it. So all these things can be do it in the networks, and these are the services. A few services just I have added here, which is called compute. Under compute, we have a Lambda, Elastic Beanstalk, a Lightsail, and compute. And coming to storage, we have a EBS, which is called Elastic Block Storage, and S3, which is called Simple Storage. Even if you want to do data analytics or big data analytics, then you have to upload your data center into the S3, and then you can add certain endpoints. Then you can analyze those data centers. Sorry, data from your machine learning techniques. You can apply machine learning techniques. You can find the valuable insights from the data. So you can keep a huge data in the S3 and Glacier. So these S3 and Elastic Block and Glacier are the various services. Glacier is the cheapest service. Only you will be use this Glacier when the data is not required, because the Glacier service is very slow. Okay, very slow. So if you require, you can historical data and all you can keep into the Glacier. Okay, only if you are using the data Glacier, then you can move your data from Glacier to S3. Even we have a intelligent storage architecture. With this intelligent storage architecture, this automatically what happen? All these data will be stored in S3 only. If suppose if you are not using the data frequently in S3 or any other storage EBS, then these data will be moved automatically to the Glacier for cost management, cost optimization. Okay, and networking. We have a Route 53, which is called DNS. Okay, DNS services, and AWS CloudFront. So we told that in the previous thing, there will be a latency when you are going with accessing the other regions, geographical regions like America or UK, okay, some other regions. Then, if I am deploying this application in the India, then some foreign countries want to access it, and immediately what happened? These data centers will be replicated to the nearest data centers. For that, AWS CloudFront is used for efficient use of web page. So our ultimate aim is whatever the data is hosted in the container, that will be provided 24 by 7. Okay, and also delay should not be happen. If you want delay should not happen, then you have to move this service. You have to add a CloudFront service to your web. Okay, that one. And management tools, which is called monitoring the services, whether there is any network failures or any attacks are coming up. So you can able to see the CloudWatch. What is the network performance? Okay. So what about data read and write? So all things can be analyzed by using CloudWatch, and cloud formation is called code deploy. You can write code, just template. Immediately you can create it 40 or 50 nodes. Okay, instantly you can able to create the nodes and add security to the nodes. okay, and add firewall settings to the nodes, and what are the packets that to be sent, and what are the packets to be allowed or denied, or everything will be done through the code itself and cloud trial. And coming to security, we have identity access management. You can create various kind of uh, roles, users, and you can add users to the group. Okay, you can assign roles to the each group or each user. Okay, or services, specific services or full services to the group that can be done through the IAM. Another one is called key management system. You can, if you want to integrate with any other application, then this key management system will be work to secure your digital infrastructure. And AWS Shield, it is one of the important one in order to avoid the DDoS attacks. Okay. For that, AWS Shield is used for your web application. Okay. So these are the applications. We have compute, and various symbols are there for each services, okay, which will be defined by the AWS. And coming to see the Gartner was defined 2019. The leaders are AWS, Google, and Microsoft are the leaders, and niche players Alibaba, IBM, Oracle. They're trying to capture the market, but AWS, Google, and Microsoft are giant in the cloud computing market. And this is the hype circle, which is the latest one. Hype circle, which is nothing but a technology. In this hype circle, all the technologies added in here. Next 20 years or next 50, now it is 25, right? Next 2025, what is the technology, what is the boon for the technology, the particular period? Okay, which one will be gone out and which will be work. So here, coming to the cloud computing will always stands, which helps for the other applications. Okay. If you want to set up any environment, you want to deploy any application, will be required the infrastructure. Will be required infrastructure for any production or any kind of application. So cloud will helps always. Okay. And this is the technology. You can go with uh, DevOps or generative AI. See now generative AI, and each they defined as the timeline 5 to 10 years and greater than 10 years. Okay, and then which is obstacle before the plateau. Okay, which will be gone out. Okay, this is the cycle. Okay, based on the cycle now itself, we can aware and you can learn this technology, and it will help in the next 5 years. That is the demand. Okay, that is the demand. So everyone must know the cloud computing, which helps for your future purpose. Okay. And see here, just I'm going to see, going to tell you about the services and how this AI, ML, and IoT and big data, okay, are used the cloud computing. So mainly cloud computing, you know, it provides only compute storage and other services. Okay, but in AML, you can apply some CNN algorithms or regressions or supervised learning algorithms or reinforcement algorithms, okay, in the AML. So main purpose is to bring a valuable insights from the data. Now the data is where these data have been collected. These data have been collected from the some IoT device, okay, some devices through sensors. All these data will be, we required more storage to store this data. So for that we required a storage. Okay. So for the storage, again we required cloud computing to create to create a large storage system for storing these kind of data, and to process such data. Again, we required a computing power. For that, again we need to go for a cloud computing, and we need to bring a valuable insights from the data to process. Okay, so large amount of data we need to process. It's called big data analytics. For that, you are applying the AML techniques to bring a valuable insights from the data. So coming to that, so everything is very important. You have to know about IoT and then AML and then big data, how cloud computing works. So this is the stack, this is the cycle. Okay. So you should not stick only on the cloud computing. Cloud computing is the area where you are going to leverage the other problems into it, and this cloud computing provides an infrastructure to the other applications. Okay. So that's all from my side. Thank you for your patience. Thank you.